And welcome to the dimension reduction course for Big Data University. In this course, I will speak about dimension reduction techniques in general, why it is useful. Then we'll focus on principal component analysis and factor analysis, including some general theoretical understanding of the analysis, some decision rules, and finally, we will have some fun with Data Scientist Workbench by IBM and examine some practical applications of PCA and EFA. You can also perform the analyses in R, but Data Scientist Workbench integrates R and Python environments quite well. So the first big question is, why should I care about the analysis? Can't I just drop all of my variables in a model and see what the output is? Well, sure, very often you can do that, especially when you're working with rather small data sets and have very specific hypotheses. However, when we are looking at the data nowadays, it is usually much more complex than 200, 300 rows of data that are described by, say, 10 or 15 variables. We live in the age of big data, which means we do not have just a handful of observations and variables. We often have hundreds or even thousands of variables that we need to analyze to identify important trends and patterns and to gain some insights about the businesses or some not-for-profit organizations to make policy decisions or even to do some basic research. Unfortunately, our mind very often cannot process this huge amount of information. We simply cannot remember each variable, and the sheer number of variables and observations makes it especially computationally taxing on the system to just drop all the variables in the model. Hence, we need a way to meaningfully chunk the data to understand and utilize it with the greatest efficiency possible. So imagine now that you have a very simple case. So you have a data table, and each row in here represents the unit of analysis, say your customers, your participants, or your items, and each column represents an attribute of that unit. For example, if your unit of analysis is customers, you might want to describe these individuals in terms of who they are, their age, their sex, their ethnicity, their personalities, and their preferences for horror movies or different types of wine, different types of pastry, and so on and so forth. Hence, you have lots and lots of variables and lots of observations stored in the same table. Now, extend this table beyond the screen, as is very typical with the big data, and imagine having 100,000 individuals in a dataset described by 500 variables, which perhaps would still be considered a small dataset. Your task now is to segment your customers, placing them in the types of people who might be interested in your product. In other words, your problem is way too many observations, and you want to chunk your observations into smaller groups of people and see how those groups of people interact with the market. On the other hand, you might be overwhelmed by the sheer number of variables in your data sets, and some variables furthermore may be highly correlated or highly similar to each other, creating some additional problems with interpretation and modeling itself. Hence, you might be interested in reducing the number of variables from, say, 500, as we were assuming that our dataset contains 500 variables, to 30 dimensions that best capture the variability in the dataset and describe the data quite well. Here, the PCA and explorator factor analysis would come in especially handy. So to recap, there are two main problems and there are two main questions. So if you have lots and lots of observations, you might be interested in how those observations hang together. So the questions of market segmentation or the types of observations come to mind quite easily. When it comes to market segmentation, you might be looking at the groups of customers who might be interested in your products. When it comes to the different types of observations, so say different kinds of wine, you might be interested in grouping these products, these wines, into groups, and then examine how each group is evaluated by your customers based on the taste, price, sweetness, and so on and so forth. So here the cluster analysis comes in as an especially useful technique. The second issue and the second question that you might be interested in revolves around way too many variables within your dataset. And you're interested to see how your variables hang together and how they can describe the dataset in the most efficient way. So here the variables may describe very similar things, and you're looking for the underlying similarity. And then you want to group those variables together into single broad dimensions that will describe your dataset most efficiently. You don't obviously want to enter all of the variables in the model. It's very often quite inefficient, it is quite computationally intensive, and you might have high correlations among variables. Most important problem, of course, is that you cannot very often keep all of the variables in mind, and you might have, say, 500, 200 variables in your model, and you're trying to interpret what each one means for your dependent variable. So here the explorator factor analysis and the principal components analysis come in as especially helpful. So having two problems, we have two solutions now. Now, for one, you might want, if you want to reduce the dimensions of your population, you might want to go for the cluster analysis. If you want to reduce the dimensions of your constructs, principal components analysis and exploratory factor analysis come in especially handy. So now I will focus very briefly on each one of those techniques and give a very short introduction before diving deeper into reducing dimensions of the constructs via principal components analysis, which I will abbreviate as PCA, and exploratory factor analysis, which I will abbreviate as EFA. So if you want to reduce the dimensions of your population, and that is your goal, then you should go for a cluster analysis. To give you a very simple example, imagine that you have a bag of seeds and you need to divide those seeds into different groups. So your variables now might be shape, they might be the color of the seed, they might be the size of the seed, and they might be the taste of the seeds. So using those variables, you might be able to group your seeds into 12 piles as described in here, putting all of the pumpkin seeds together, putting all of the sunflower seeds together, and basically creating the groups of observations. So you're retaining all of the observations together. What you're simply doing is placing each observation into different groups. When it comes to the real data, so the more familiar case for many of us is looking at data tables, we have a whole bunch of observations represented by each row, and we're grouping the rows based on the variables of interest. So here you have the blue cluster, you have the red cluster, and the green cluster. So the cluster analysis allows us to statistically put people into groups. If you're interested in cluster analysis, I do recommend you check out the course offered by the Big Data University that covers the k-means clustering, hierarchical clustering, and density-based clustering. In the current series of lectures, I will concentrate primarily on the second goal, which is reducing the dimensions of the constructs via principal components analysis and exploratory factor analysis. In this particular case, you might have several variables. So here you have teaching skills, social anxiety, eats pizza, presentation, communication, and nonverbal skills. And what you're trying to identify is whether those different variables can be represented via just one dimension called social skills. You can imagine that teaching skills, social anxiety, presentation, communication, and verbal will all be good indicators of an individual having good social skills, not necessarily eating pizza per se. So hence you have a dashed line to eating pizza, meaning that we will be dropping that variable and not including it in the dimension. So going back to our table, so instead of partitioning the rows of the data, now you're going to be partitioning the columns of the data and underline the similarity between different observations. Hence, it is going to be the goal of the principal component and factor analysis.